6. Here we go, chapter 10. So we are still doing systems. The only difference is it's not systems of equations, it's systems of inequalities, which means we're going to have alligator mouths. Okay? Systems of inequalities can still be in y equals mx plus b. They can also be in standard form, ax plus by equals c. I'm not going to lie, every time it will be in standard form. Okay? We do not usually write inequalities in slope-intercept form. So 99.9% of the time, we will be focusing our efforts on standard form. Okay, standard form. When we graph an inequality, you'll notice they look a little bit different, don't they? Okay, when we graph an inequality, not only will there be a line on our graph, but we're going to need to shade either above that line or below that line. Since inequalities are greater than or less than, our solutions are going to be anywhere above a line or below a line. And the last little thing we need to talk about is sometimes you're going to graph dotted lines today, and sometimes you will graph solid lines. Okay? If you are using just a greater than or a less than sign without the little line underneath, you're going to use a dotted line. And that's because if I said you have to have more than 10 fishies, are you allowed to have 10 fish? Or do you have to have at least 11? You have to have 11. If I say you have to have more than $10, you couldn't show up with $10, you'd have to have more than $10. Okay? If I said you have to have less than 5 referrals, okay? 5 referrals is too many. You have to have less than 5, okay? So those are going to get a dotted line because any point on that dotted line isn't going to count as a solution. When we have a greater than or equals to, or a less than or equals to with that line under the inequality, then you're going to graph a solid line. A solid line. If I say you have to have at least $10, then you're allowed to have $10 because you still have at least that much. Okay? Before we get into it, let's talk about solutions. Before, the solution to a system was where the two lines did what? Crisscross applesauce. A system of equation is going to be where the two shaded regions intersect. Okay? So that's why we're going to use two different colors when we graph these. You're going to shade in one color, shade in the other color, and where those two shaded colors overlap, any point there is going to be a solution. Okay? So a solution is any point that's in both shaded regions. For example, if we take the point -3, -3, look at -3, 3. Do you see how that point is in the double shaded region, right? See how it's in the shaded region? That's a solution. If your point is on a solid line, that counts. For example, the point 0, 3. 0, 3 is on the solid line. That's allowed. Being on a solid line counts. Okay, being in the shaded region, great. On a solid line, great. That's a solution. If your point is on a dotted line, for example, -3, 2, this point is on a solid line and a dotted line. Being on a solid line is good. That counts as being on that line. But on a dotted line, the point falls through the cracks and dies. Okay? This does not count as a solution because it's on the dot. One of the lines it's on is dotted. And then, of course, if you have a point that's outside and not on any of your lines or any of the shaded regions, that is not a solution. Okay? So inequalities have many, many, many solutions, not just one. So let's do it. sure you got Desmos ready to go. Example 1, get your 2 colored pencils. Okay, we are going to graph example 1, pull up Desmos, and here we're about to do it. Bro, turn your music off. Okay, so I have Desmos open. The first thing I'm going to do is type in both of these like we did before. Y is less than 3. Y, open up my keyboard, less than 3. And you're going to see a big shaded region pop up on my graph. It's a dotted line because it's a less than sign. My other one, Y is less than or equal to negative x plus 1. Okay, so here is what I am looking at right now. So I'm going to take my first color, whatever color it is you have, and I'm going to plot the line 0.03 and draw a dotted line across it. So I plot 0, 3, 1, 2, 3, and I'm going to graph a dotted line. It's dotted because this is a less than sign. And I'm going to shade everywhere underneath. So take your colored pencil and give it a nice shading everywhere underneath. Everywhere underneath. Give it a nice color. Now we're going to do the same thing with our other line. Okay, I'm going to hide this red one and pop up my blue one. Okay, I'm going to click on my line and find 2 pretty points, 0, 1, 1, 0. And draw a solid line in my second color. 0, 1, 1, 0. Ready? 0, 1, 1, 0. Solid line. And I'm going to shade everywhere below, just like it shows us in Desmos. Everywhere below. Just ignore the other color. It's going to be everywhere below. Just like that. Yeah, I'll get that later. Okay, our 2 shaded regions, our red and our blue, overlap right here. Right here is where both colors touch. Okay? This is where both colors touch. Where your 2 color pencil colors overlap, that's where all of our solutions are. Okay? So that is what the graph of our inequality looks like. Yeah. Oh, that's okay. Just keep following along. Okay. Your equations are different for some reason. You can just switch them. Okay, so graph the system of inequalities. Perfect. Number 2. All I need you to do is find 2 possible solutions. So find 2 points on your graph that are in the double shaded region where your 2 colors overlap. For example, if I pick the point 0, negative 3, that's negative 2. 0, negative 3, right there. The point 0, negative 3 is in the red, and it's in my blue. It's in both shaded regions. So the point 0, negative 3, that's a solution. Yeah. 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 The point negative 1, 2, 3, 4, 5. Negative 5, 1. That point is in both shaded regions. That's another possibility. Okay? Any point in your double shaded region is a solution. Okay, now let's check these. Go on your graph and plot the point 1, 2. Let's plot the point 1, 2, and I'm going to pull up Desmos for this. If I pull up Desmos and I put in the point 1, 2. See it right here? Is this a solution? It's in the red, but is it in the blue? No. That is not a solution. Let's try another one. Let's try 0, 1. 0, 1. Boom, right here. This one's tricky. Is it in the red? Right? It's in the red. Does this count as being on the blue? Is this on the blue? Being on a solid line counts, right? So this is a solution. 0, 1 is a solution. Next one. Negative 2, 3. Right here. What do you think? Negative 2, 3. Negative 2, 3. Is it on the blue line? Is it in the blue? Yes. It is on a solid blue line that counts as touching blue. Is this on the red line? That red dotted line? Does being on a dotted line count as being on the red? This counts as being on blue, but this does not count as touching red because it's on a dotted red line. Dotted, you fall through the cracks and you die. Not a solution. Point 0, 0. Yes. Here's my red point 0, 0. It is in the red, and it is in the blue. That is a solution. So our two solutions here are 0, 0 and 0, 1. Again, I think yours might be a different version, but 0, 0 and 0, 1. Those are our solutions. Done. Next problem. Next problem. Open up Desmos and plug it in. Open up Desmos and plug it in. X plus y is greater than 2. 2x minus y is greater than 1. Here's what my beautiful graph looks like. Why are both my lines dotted? because they're just greater thans. They don't have the or equals to part. So they're dotted lines. So being on those dotted lines are not going to count as solutions. Remember, a good way to graph these is pick two nice points. Okay? Pick two nice points on the graph, like here's 1, 1, and 0, -1 for blue. Okay? You could plot this, 0.5, it's not the greatest point, but you could. Pick 2 points, plot them. My blue line, -1, 1, 1. Oop, dotted. Dotted line, and I got a shade under. Take my highlighter, you take your colored pencil, give it a little shade. There's one of my lines. Okay, I'm going to go to my red line. Pick 2 pretty points. I got 0, 2, and 2, 0. So up 2 and right 2. Plot my points. Up 2, right 2. Dotted line. And I need to shade above this line. Take your color and shade above. Just like that. My 2 colored regions overlap right here. This is where my colors overlap. Which means my solutions are any point in that double shaded region. I colored it green so you can see a little better. Okay, so take a second. What are 2 possible solutions? What are 2 possible solutions? Find 2 points that are inside the double shaded regions, the green regions, where both colors touch. 2 points. Tons to pick from. If I count over 4 up 1 is the point 4, 1. Okay, that could be 1. If I went over 10 up 2, 10, 2, that's in the double shaded region. Okay, any point that's in my green region is a solution to the inequality system. Okay, 4, 1 could be 1. 10, 2 could be 1. There's so many to pick from. As long as it's in both shaded regions, you are good to go. Okay? I got it on 5, 5, 0, 5, -1, 6, -3. Any point that's inside my double shaded region, you're good to go. Okay, let's figure out which of these is solution. So I go into Desmos, and let's type in my first one, the point 2, 0. Type in the point 2, 0. Find it right there. Do you see it? See it right here? Is 2, 0 a solution? Is it in both my red and my green? Or red and my blue? A good way to tell, too, is let's hide one of them. Is that green dot in the blue area? Yeah, it's definitely in blue. Does this count as being in the red? Does being on a dotted line count? It actually does not. being on a dotted line doesn't count as touching the color. If that red line was a solid line, it would count. But this does not count as being on red, so is this a solution? No. Let's try 0, 2. 0, 2. Is this point a solution? No. What color is it? It's not on red, and it's not in blue. Definitely not. 1, 1. If I type in 1, 1 right here, again, if I hide, is that on the blue? Nope, it's on a dotted line. Is that on the red? Nope, dotted line. 1, 1, not a solution. All we have left is 3, 1. 3, 1. Is this point in both the blue and the red? Yeah, look. Red, blue. Red, blue, red, blue, red, blue, red, blue. It is in both. The only one of these that's good is 3, 1. Beautiful. Yes. Systems of equations and inequalities. Alright, we just have 3 quick problems to do and we're done with our notes for the entire week. No. Okay. Let's do a story problem. Yay, your favorite. These are exactly like what you just did. The only difference is instead of having equal signs, we're going to have alligator mouths. Okay, all of your problems will be in standard form for inequalities. Equations last week, remember sometimes it was y equals mx plus b. This week, standard form. You are planning a pizza party and want to order more than 10 pizzas in total, with cheese pizzas costing $8 each and pepperonis costing $10 each. You have a budget of $100. Write a system of inequalities to represent the number of cheese and pepperoni pizzas you can buy. Okay? Our first goal is creating our two inequalities. So let's highlight our important facts. We want to order more than 10 pizzas. Cheese pizzas are $8 each. Pepperoni pizzas are $10 each. You have a budget of $100. Let's write a system. Okay, now the first thing I need to do is I'm going to write down my two inequalities, my equations. So remember last week when we were doing standard form, what 3 numbers definitely go together? What 3 of my numbers are going to go together? I have my $8, I have my $10, and I have a budget of $100. Why do all 3 of these go together? Because they're all money. Okay, so my first equation is going to be, what's it going to be? ax plus by. 8x plus 10y. And now here's where we got to be super careful. It's not going to be equals. My budget is $100, which means how much am I allowed to spend? Can I spend $100? Yeah. Can I spend $50? Yeah. What can I do? I can't spend more than $100. So I don't have to write an equal sign because this just says my budget. It doesn't say you spent $100. You have to spend $100. We can spend anything less than or equal to. So less than or equals to 100. That's my equation, or my inequality for my price. So look, I'm done with 100, I'm done with 8, I'm done with 10, and all I have left is more than 10 pizzas. We want to order more than, yep, so we need to do x plus y. And I want to spend more than 10 pizzas. So what alligator mouth am I going to use? Greater than, is it going to be or equals to? Because it's strictly more than 10. I can't get 10 pizzas, I need to get more than 10. So greater than 10. These are my two inequalities that make up my system. And now we can find all the different possibilities that we can buy using Desmos. That was nice, and I'm not going to make you graph it. Okay, but we are going to type them in. 8x plus 10y is less than or equal to, is that right? Less than or equal to 100. And x plus y is greater than 10. And here is what my graph looks like. Okay? Our first problem asks us, is it possible to buy 6 cheese and what, 6 pepperoni? 6 cheese, 6 pepperoni. So as a point, that's the point 6, 6. 6, comma 6. I'm going to take a look at my point. Is my point 6, 6, 6 cheese, 6 pepperoni, is that in both shaded regions? No. It's not. Can we buy 6 cheese and 6 pepperonis? No. We're going to be over our budget. Okay? So no, we cannot buy. No. We cannot afford 6 cheese pizzas and 6 pepperoni pizzas. Now let's find 2 possible combinations we can order. Again, if we go into Desmos, I just need to find 2 points that are inside the shaded region. Okay, so if I look here, I can see 5, 6, 7. If I go over 8 and up 3, you see this point right here? Isn't that in both shaded regions? That would be 8, 3. Let's see. Well, here's 8, 3. You could get 8 cheese and 3 pepperoni. What did you say, Darren? Let's see if 0, 1 works. 0, 1. This is the point 0, 1. Now, what's wrong with this?
Oh, I thought that was 0.
Where? Oh, right here? No, that's 10. Okay, but 8, 3 definitely works. What's another one that would work? Let's try 6, 5. 6, 5, that's in both shaded regions. Let's try 0, 2. Is 0, 2 in both?
I mean, I meant to say 10, 2. That's what
10, 2. Let's try 10, 2. 10, 2, that works because it's on a solid line, and solid lines count. See? Any points that are in both areas, there's 3 possibilities right there. Okay? 3 possibilities right there. So we're not looking just where they cross. We were looking for where our shaded colors cross. So 6 cheese, 5 pepperonis. 8 cheese, 3 pepperonis. 10 cheese, 2 pepperoni. All of those are possible combinations that stay within our budget. And also allows us to get more than 10 pizzas. Okay? So you can write down any of the 2. Any of those 2. Alright. We got time for one more. Yes. Okay. Example 4. Go ahead, read the problem and highlight what is important. What?
I gotta go to Mr. Lee.
Okay. Well, you can come anytime this week.
Alright.
The girls swim team is hosting a fundraiser. They would like to raise at least $500. They're selling candles for $5 and flower arrangements for $6. The girls estimate that they will sell 200. Most likely, at most, they will sell 200 items. What are the giveaways that this is going to be an inequality and not an equation? Yeah, we got the word at least. We have the word at most, right? It's not telling us exactly, but it's like estimating. Okay, so we got, they're going to need to raise at least 500. Candles are $5, flower arrangements are $6, and they estimate that they will sell at most 200 items. Okay? Now again, when we set up our first inequality, we're trying to see what three numbers go together. Exactly, we got 500, $5, and 6. And those are all going to go together because they all are talking about money. They're all talking about money. So how do I write my equation in standard form? What two numbers are going to go in for A and B? 5 and 6. Yep, 5x plus 6y, and here's where we got to be careful. They want to raise at least $500. So we're going to have to put in 500 for C, but we need to know what alligator mouth, right? It's going to be some type of alligator mouth and then 500. So do we want to spend more than, or do we want to make more than 500, less than 500, exactly 500? How much do we want? A good way to figure it out is, I get it says at least. But like, think of this in context. Could you get exactly $500 and make our goal? Right? Since we can get exactly 500, we know we're going to have the line underneath. Would you make your goal if you got $600? $700? $1,000? Those are all good numbers, right? Now, would it be good if we made $400? So, instead of saying at least, wouldn't you say we need to make more than, greater than? At least means we need to make more than or equal to. So greater than. We read our alligator mouse left to right. The big side's on the left, greater than. So far. Yes. Yep. Darren, you need to go down to 135. Second equation. All we have left is we have to, at most, they will sell 200 items. So we're going to have our x plus y, and it's going to be something 200. We just have to figure out what type of alligator mouth do we use for at most. A what? Less than or equal to. We can sell 200 and anything less than that. We're not going to be able to sell more than 200 items. You got your 2. Our first question says, if the girls sold 80 candles, what's a reasonable amount of flower arrangements they must sell in order to reach their goal? Let's type these bad boys in. Open up this old one. I'm going to clear it out. Gear, delete all. Here we go. 5x plus 6y is greater than or equal to 500. I can't see it, so I'm going to zoom out. Okay. My second one, x plus y, what was it? Less than or equal to? 200. Here's what my gross nasty little graph looks like. I got my red and my blue. My solutions are anywhere where blue and red cross. intersect, anywhere inside of here. If they sell 80 candles, okay, that's X. Let's figure out how many flower arrangements they could have possibly sold. So let's pick a number. Let's say they sold 50 and just see. If they sell 50, is that good? Yeah. If they sell 90, does that work? Yes. If they sell too many, though, like 200, that's way, way, way too many. Okay? So we're finding an amount of flowers that gets us in the double shaded region. So 80 candles, 50 flower arrangements. You got another one? If they're 80 and 50, that works as well. Yeah, 80, 50. Boop. 80 means we can do 50 flowers. Would work. Yes, Valerie? Okay, let's try B. If the swim team sold 50 candles and 30 flower arrangements, will they have reached their goal? So in Desmos, what would we type in? We type in the point. 50 for candles. 30 for flower arrangements. We see our point. 50, 30. No siree. It's in the blue, but it's not in the... So, that's not... We didn't reach our goal. If we did 50 flowers, 30 flower arrangements, we would not reach our goal. Hmm?
Oh. I made another one.
Oh. No. No, they wouldn't reach the goal. Sad.